I'm David, you might see me around. I'm a chronically unemployed engineer, and in my ample free time I make space guns. So this is the first and possibly last ever space gun. It's a double-barreled shotgun with a rifle barrel and a machete in the stock. Naturally it was built by the Russians. Their cosmonauts took it up with them on their missions in case the pods landed somewhere in the wilderness and they had to fight off bears. That's the most interesting part of my presentation because I make fake space guns. I take guns from video games you see around. Anyone ever played Mass Effect? Yeah? Overwatch? Yeah? So I like to make replica props of these weapons that I see. Lots of people do this. It's called cosplay. A lot of you may have heard of it already. But they tend to make just static, beautifully made, but very static, solid lumps of plastic. I try and replicate what the weapon does in the game, just without the actual shooty bit. Yeah, so if any of the esteemed members of the authorities are here, not actual guns. And this is a little preview of what it does.
I think you may
Click
have
out
to.
of the video
Yeah.
so it thinks it's
There we go. So I got my start at MATLAB. Just after university, I was trying to find something to do, and MATLAB was the local makerspace in the area. I'd never really made anything before. I bit things out of cardboard, but nothing really serious. And there were a lot of really skilled, a lot of really creative people at MATLAB who were doing a lot of very serious design work. And we had a lot of fun building all kinds of crazy things. And as I said, it's a very serious business at MATLAB. And they all encouraged me to do a project. And I'd been wanting to do these space guns I'd seen for a while. The guy on the far right there is called Tom. He owns his own prop making business. So he thought what I was trying to do was really exciting, and he really pushed me to do it. So I gave it a shot. But for my space guns, I tried to have certain criteria I wanted to follow. Firstly, as you already know, not be a real gun. Have to point that out. Secondly, it has to look as close to the original as possible. I didn't want any compromises on the look of it to make it work. I didn't want to make it oversized, so I wanted to make it as close to the original size as possible. I also wanted to move like you saw in the game, because that was the really unique part of this, as no one else had done it before. I also wanted to make it repairable. I didn't want to use lots of glue, because that meant if I built it and something didn't work on the inside, I'd have to break it open and start over again. And if other people wanted to make this as well, then they could fix it if something goes wrong. So it's just a bit more friendly or environmentally friendly that way, so you don't have to throw it away every time you get it. Yes, of course, sorry, I have to point that out. Right, so M3 Predator Pistol. This is from Mass Effect. Some of you already know it. It's a sci-fi space opera game, lots of shooting in space, hence why I started calling this project Space Guns. It stars Commander Shepard, who goes around shooting lots of everything, actually. This is the gun in the game. As you can see, it likes to fold into itself, and I first saw that, I thought that was the most amazing thing ever, and I really wanted to try and make one. And you can kind of see how it works in this video, though the screen's a bit small. You can kind of see it, there you go, folding into itself, and yeah, you might have already spotted a problem there. Trying to build this in the real world. Yeah, space guns don't obey the laws of physics. That was a bit of a problem. So I had to compromise a little bit, get rid of that point. So I couldn't make it move exactly like the original, but I was going to get as close as I possibly could. So keep going. Now I need to get the correct size of the space gun. So you just use proportional mathematics. you say that's the hand of Commander Shepard, our protagonist. It's about that high, and then we've got about 1, 2, 3, 4, and that's a very big space gun. Yeah. So Commander Shepard has tiny hands. So maybe not the original size, maybe something that looks a bit more realistic on a real human being. So carried on regardless, and the first thing I did is make a beautiful CAD model in Fusion 360. It's one I did talk at the very start of the Maker group. And this was the first time I used it, but not the first time I've done CAD. I had a lot of experience with that from my engineering degree. It's really good software. You should try it out if you ever get the chance. The first prototype was just very simple. I'd never really, as I said, made something this serious before. I'd never used a 3D printer before, so everyone at MacLab just kind of encouraged me to give it a go, see if it comes out. So the very basic concept was there, the folding worked. You could get some of the ideas I needed to incorporate, like the handle has to collapse into the guard because there's just not enough room. So that part has to have little flaps and trapdoors into it. You need this little pin here, slides along inside there just to keep the shape as it collapses. So that's the main concept was there. The second prototype was actually going to function. So the biggest problem with making these space guns right from the very start is they're not designed to work in the real world. The challenge is making something that's supposed to be physically impossible actually possible. So fitting mechanisms into places they were never meant to go, and finding the space to do it was always the biggest problem. So instead of having neat little rods or things connecting every part that moved, every part actually chains off itself. So this moves everything. It pushes that barrel pushes that barrel pushes the cap at the top, and then again we've got this part which moves the guard, which then drags out the handle, which is spring loaded to push the door here and the door there and the little flap at the back. And this part here is meant to be a little latch, so you can just push it, holds it in one place, push it, holds it in the other place. So everything works perfectly fine in CAD. Unfortunately, CAD really isn't the real world. So I had to go through quite a few different ideas. Not every one of them I could put up here. Some of the springs to move the doors didn't work. This latch was a total failure because it just wasn't a big enough turning moment on the lever to make everything move. The pin that holds the handle to the main body, that kept jamming. I tried to make tiny linkages, I'm not sure you can see it on that picture, out of acrylic. And it turns out using tiny acrylic is not a good idea, it just breaks. So the hardest part of this build was this stupid triangle. And again, I'm a bit of my own worst enemy. I wanted it to look as accurate as it possibly could from the game, and in the game that triangle's there. And honestly, I like a good challenge. I really enjoyed this project simply because it was so difficult. I had a few ideas. The first one was to make these triangles sort of move in and out so that the handle could move in between them. And this was a great idea in principle, but everything just bent out of shape in the wrong way, and it was too much friction. So the idea I went with in the end was to narrow things a bit so the handle could still move between them, but we have this little flap which is in the back of the handle that can fold into itself, and then and you can see it opens out and forms the back of the triangle at the end. And these triangles will then slot into that part there. And then there's another panel, not in the photo because I foolishly didn't take a photo of that, which hides the triangles when it's folded up. Yeah, it's really simple. As my friends at MacLab kept telling me, this was quite complicated, and I never thought it was complicated because it was all in my head and it all makes sense. But now that I look at these pictures, going back on it, there's a few moving parts to it in different places with springs and rubber bands. Mostly everything was custom made. yeah, you can see the handle there had to squeeze into itself, and just to do that I've got 2 springs of rubber band using a pin needle as a hinge. This part works surprisingly well, actually. So the second prototype was a success. I used a spring to actuate it, hold it onto the guard, which then rotated this part, which pushed everything out, and it all collapsed and folded neatly in itself. But as I said, the latch failed, so you had to physically hold it in with your hands. But as a proof that this mechanism can work, yeah, came out great. But the original idea was always to make this electric. You push a button and it opens, you push a button and it closes. I couldn't help myself. But I quickly discovered how big motors are. As that's a 9-gram servo, that's about that big. And that's the only space I had left. So I can't put that nice little wheel thing, or lever system I had to come up with a completely new mechanism to make everything move. So I had to come up with a lot of different ideas. The first one was a gearbox. What I was going to do was I was going to have nylon fishing wire attaching to certain parts that could push or pull, and then the barrels were on a rack and pinion, which would just sort of slot in here. And there's a pulley here, you can see in the next slide, that you can just about make out the fishing wire. It was a terrible idea, as fishing wire is really hard to tie, especially in tension in a mechanism like that. I almost gave up making this thing at this point. So I moved on to this idea, which was kind of just a joke in my head. I didn't think this would work. I ended up printing my own lead screw. I don't know why I decided not to just use a bolt or something. There was a reason. I can't remember. But this turned out surprisingly well. I had to print it in 2 halves to get it as smooth as possible and then glue it together. But it worked. You can use this gear motor, which is always at servo, so it's always at 1000 to 1 already, and then add a lead screw, so there's quite a bit of torque in this, and it needed it. And you can see I had to make custom housing just hold the motor in the exact right place on the bottom plate. You can just about make out sort of the limit switches. These are the tiniest limit switches you can buy, and I thought they were too big for the job. Yeah, friction became a problem, as always does in mechanisms. I had to use some slick tape. I think it's UMHW or something. It's a bit like Teflon tape. It's really smooth, and it didn't work at all. So I came up with my own bearings, which was made out of sewing pins and really, really thin rollers, just laser cut on acrylic. And surprisingly, that did work, but all those pins weren't held in by anything, so if you got the assembly wrong at any point, they'd go everywhere, all over the floor, and never to be seen again. So I made a lot of those. Latches. So I told you that the first latch design didn't work, so I had to make another one. But I didn't have the space I had before to do it in, so I had to find some more room. And I found it in the least likely place possible, which is right at the very end in the narrowest part of the space gun. I actually amazed myself by making this. This video might work. It has 2 latches, the blue part and this part here, which holds on to different pieces, whether the thing's open or, okay, no, open or closed. Really quick, as you can see it. Yeah, so the idea of putting it here was it holds it in the ideal place, the longest arm of the lever rather than the shortest arm of the lever, so that it doesn't require that much force and there won't be much movement when it's holding it. And you can see that's the end of the guard, which gets caught by those latches, and that's the pin onto the handle, which gets caught by this latch, and that's a custom spring I made out of just bent wire. life a little more difficult for myself, but also really fun challenge. I wanted it to just work on one button push. So if the latches were at the very end of the gun, then the button to work it had to be at the very end of the gun. And that's a 5mm latching switch. That would have made things really simple. It was too big. So that is a 2mm momentary switch, which I housed in this little custom circuit on this cap that fits at the very end of the gun. And because this piece is removable so you can take it all apart, I had to add pins and sockets on either end. That was just done with a Dremel and a bit of hot glue and a lot of hope. I had a lot of trouble with those pins. Then we need power. I've used up almost all the space now. The mechanisms in the largest space I had, there's a circuit and another small space, so this has to go into the guard. I found these are for recharging your phones. I just took one of those battery packs apart, pulled out the battery out of it, pulled the circuit out of it, so the idea was you just plug a nano USB cable into it, it recharges it. It'd be great. It fitted perfectly, and then I broke the circuit that recharges it, and I couldn't find a similar one in that size. So I ended up making my own custom battery pack of just 3 AAA batteries, and I hid the switch that turned everything on in the front panel of the guard, which could be removed, so the switch was hidden behind a feature of the gun, so I managed to keep the original look of the whole thing without having an unsightly switch on it. Then I made a logic circuit, or probably made a logic circuit for this. Might be a bit out of order. Because it was a momentary switch, it wasn't a latching switch. If it was a latching switch, you just press it and then the motors turn until it reaches the end, push it again, goes out the other way. Momentary switch is just on off, on off. So I had to make a logic circuit that said, button pushed, what direct, am I open, am I closed? If I'm closed, open, if I'm open, closed. So I used a D flip-flop, which is a technical term for a circuit, in case anyone didn't know. And it was housed with a relay, so that would turn on the motor. And every time you pushed the button, it clocked the flip-flop, and the tiny, tiny little flat end switches gave the state, as it were, whether it was open, whether it closed. And that was a lot of work. When I originally made the CAD for the model, I foolishly assumed that things like wires had no width. Because, you know, wires are really small and they're really thin, they don't matter. But when you're working with this kind of space, they really, really do matter. Some of the wire I used was the thinnest you can get, which is motor winding wire. So if you ever find an electric motor and take it apart, the wire they use to make the coils, that's what I used, and it's really, really hard to solder. Now I have to attach the LEDs. There's beautiful LEDs in the gun and the game, and everything obviously looks better with LEDs. But because everything was in 2 halves, I had to get power from one side to the other, but having just connections you put together and then shows cut, there's too much space. There's never enough space in this gun. Oh, sorry, I didn't mean to make a pun there. So I used just sticky back copper vinyl strips between the 2 parts, one of the only 2 parts of the gun that actually fits together, using some of that really thin motor winding wire, so the 2 halves were bridged together. Used tiny surface mount resistor and LED on, that's a piece of Vero board that I had to cut and file into shape to fit into the tiny holes where you can see the LEDs in that picture. And it's all held together with one M3 screw right through the middle there. And it worked. It took a lot of time, a lot of tweaking, and a huge amount of lubrication, but it worked. And you can see everything going there. So I had to move on to, I don't know, gotta click away again. Painting. I have to thank Tom, again, the guy I mentioned before. He's got his own props workshop and he had all the airbrushing, painting equipment, and he taught me everything. So I used a spray-on filler primer, usually used for car bodies, which got rid of all the lines in the print. I sprayed it on with car paints you can get out of Halfords, which comes out surprisingly well. And then I moved on to using an airbrush to get all the little details and masked it off with vinyl that I cut at the Mac Lab. And you can use tomato ketchup, of all things, as a sort of weathering tool. You just sort of flick it on and then spray over it, and then you just wipe the ketchup off, and then you've got paint chips, like it would in a, you know, a used space gun, as it were. The rest of the colors were added with watered down acrylics. You just sort of wipe them on and then wipe them off, and you get this kind of wash effect. I'm red-green colorblind, so my first pass at this apparently was very, very green, and Tom had to tell me otherwise, and I take his word for it because his work's amazing. And then you just use a silver dry brush, that's it, for the edges to make them look like they're worn off and you can get to the metal underneath. And you get a very pretty looking space gun. So that is the finished space gun. I put this up on the internet, and within the space of a couple of days it had about 90,000 views, thousands of shares, and I was having a mild panic attack at that point because I'm not used to that much attention. It looks like it works great in the video. That was several takes. This thing wasn't as reliable as I wanted it to be, but as my first proper making project, I think it came out okay. So with all that attention on the internet, with all the time and effort it's gone into it, and with Tom and the people at MacLab encouraging me, they encouraged me to try and make something out of this. So I'm making a side business thing. I'm not entirely sure what it is yet. I'm calling myself Optimistic Geometry because my designs are very optimistic and I'm not, so the optimism is ironic. I had to come up with a logo for it. Obviously the first one, very optimistic geometry, but not a great look, so I came up with the one on the right with a bit of help from Andrew from the Mac Lab, and that's the one I've stuck with since. The motorized version took forever to build, was very, very tricky to make. So there's no way I could sell that without a lot more development time. But the second prototype worked pretty well with a little tweaking. I got a spring-loaded version of it working. I put that up for sale on the internet, and I managed to get a couple sales of it. I started selling the fully painted version of it. I started selling kits of it. I started selling the plans if you want it. They're up on Etsy, so you can download 3D printing files and some instructions. You can make one of these yourself if you've got a huge amount of spare time. So I had to make huge amounts of social media. I've got Facebook, Instagram, YouTube. Not much of it's updated except the Facebook page and the Instagram now, kind of. I've made my own website where I put my work on display, and I'm saying I'm taking commissions if anyone wants to try and commission me to do something. I'm almost hoping they won't because I'm terrified of other people, but I do enjoy a good challenge. So this is a point where I say, are there any questions? But do we have more time? Because
We're fine for another 7 odd minutes. What I'd actually calculated was when the next set of pizzas arrives. So we have
so we can have 7 minutes of questions or 7 minutes more space guns.
your choice.
Space guns.
Space guns? Okay. Yeah. There's always more space gun because I never stopped. I love this. This one's from Overwatch, as I mentioned earlier, game made by Blizzard, massively popular, turning it into an esport. They've got a character called D.Va, who really is just them. I can't say the word, I think of it, but it's a bit of an ego trip for them. But this is her space gun. I don't think she technically goes to space, but we'll ignore that. So I wanted this to be a simpler project. The last project took forever, very complicated, very tricky. This one, all I said, okay, turn it into a Nerf gun. That should be easy enough. There's plenty of those on the internet. It'll just, you know, fire some bullets up there, put some flywheels in there, that'll shoot it out, and we can make some kind of mechanism to make the hammer go back so it's got real looking action. Simple enough. Hasbro and Blizzard very recently partnered up to say they're going to make Nerf guns of Overwatch characters. So yeah, they could sue me at some point.
You might give me a job.
That's the optimistic option.
Well, buy your design.
So start with a CAD model. This is my second Space Gun CAD model in Fusion 360. I got a lot better at making renders at this point. And I still got a lot to learn, but I think they turned out pretty well. Then I discovered while researching the gun, it fires like a cannon. So most guns, just the hammer at the back comes backs and forwards. You know, fire, hits the bullet, shoots it out. This one, the barrel at the front moves with the hammer at the back, so the whole thing goes backwards and forwards. So I somehow have to connect that part up with that part, which caused a lot of trouble. Then, yeah, you know how I wanted to make it to scale, same size. Wasn't going to happen on this one either, because Nerf darts are surprisingly big, especially if you want to keep the same proportional size of the barrel. So I had to scale up. That is the correct size of D.Va's light pistol for a small Korean person. This is twice the size. This is my Nerf gun. All so I can fit a Nerf dart through the front, which led to problems of 3D printing, because I usually use an Ultimaker. It's got a reasonably sized bed, but not big enough to print this space gun. So it's going to get split into 3 parts. But that causes problems with alignment of mechanisms. It's very nice if you've got a long flat sheet, everything lines up. When you have to line 3 parts up to make that flat sheet, something's going to be a little off, and that makes the mechanism jam a bit more, so it makes it tricky. This is me coming up with concepts. So, because Nerf darts are big, they can't go up where the magazine would normally be. In fact, the way I looked at it, pretty much nothing could go up where the magazine would normally be, because the trigger goes into this cavity here. Again, it's just video game developers being really inconsiderate of my feelings. So I had to move the Nerf darts into the only place that would fit, and thankfully there was a feature here that I could hide them behind. That magazine becomes where the battery lives, which would be kind of cool if you take the magazine out and the power goes off to your gun, so that's still pretty cool. Then I'm going to have a mechanism up here again to have the hammers going back, and this is where the levers move everything, push the Nerf dart into the flywheels out the barrel. I went with a mechanical design for the hammer mechanism. I could have gone with an electric design, might have made my life easier, I don't know, but I like mechanical things, so I wanted to give this one a try. So what happens here is there's a trigger point in this sled here, so that pushes that back against the spring, and when that lever passes the point, the trigger point, this shoots out, pushes this, which is attached to the hammer, that comes out, and then it slides over the top of it, and you get this sort of reciprocating mechanism. That's the whole basic concept put together. Very simple again. The motors were a pain in this part. Again, they're just not designed for real mechanisms, these things. And motors are surprisingly big. So the flywheel's going to live up here, but the motors could only fit down here, so I have to create some kind of pulley system to get the drive power to the flywheels. And that caused me a lot of trouble. So I had a surprising amount of success. I took a lot of the lessons I learned from the first space gun, and my first prototype of this one turned out surprisingly well. This is that lobe where I'm going to put the Nerf darts up here, and this is just a little, that's just a feature of the gun, that it's actually a spring clip. So you push it and then you can take the magazine out, so there's no visible buttons or switches again. Those are the tiniest bearings I could get for a 2mm steel shaft. That's a 1p piece next to it. That's for the whole pulley system. These are my battery contacts. They're just contacts that you would find at any AAA, AA battery holder. You just pull those out. You can actually order them off Rapid or RS, and they slip into anywhere you want them really, really easily. The only problem is they're a bit stiff, so you need quite a bit of force to make the contact. And that's where the motors and pulleys are sitting in the gun. But again, motors are the bane of my life in these projects. I made a beautiful custom housing for them, channels for the pulleys to go up. I actually ended up ordering the wrong size of pulley, as you can see there. It's a little big. What was it? I ordered by radius and not circumference or something. So I was out by pi, a factor of pi on that. But as I found, pulleys are quite hard to pull off, especially in a really small space. And there's quite a bit of resistance to pulley movement unless you get the right type of belts. So that just wasn't working out for me. Came up with another design, which is bevel gears. Got them off a model train website. That worked great, but gears are really quite noisy. And then I had an embarrassing revelation, which you might be able to see in this video. See, I've been looking at it from the wrong perspective. That's where the flywheels would normally sit, and oh, I can just turn them by 90 degrees and connect the motor straight to it. Oh, yeah, that was a head desk kind of moment at that point, because I had so much trouble getting those motors in place, getting this part to move round the flywheels. It was such a pain. It was quite funny how I missed that, but it's interesting how you can look at a project in the same way the whole time and not think there's any way to ever do it, but if you just sort of shift your perspective from 90 degrees, everything changes. So this one was the barrel. As I said, the barrel has to move. So the dart has to go into a moving barrel somehow. It has to bridge a gap between where we fire out of and this section where it moves in and out of. My first idea was to make a cone that it fires. So the idea was it would sort of hit the cone and go through there. Another optimistic design of mine didn't work very well. The dart would just sort of hit there, and because it's got a soft rubbery nose, it just sort of hits it and all the momentum dies. So the second idea was to make a moving barrel which was just half a cylinder. So the flywheels could sit in the middle of the cylinder, and then it was held at the top and bottom. And that worked quite well, but these prongs here moved into where the magazine was and would jam on other parts of the gun or other Nerf darts in the magazine. And so it didn't work out, oops, wrong way, quite so well. But what it did do was let me shoot exactly one dart, and that's good enough for a video. Yeah, I think the frame rate's too slow, but a Nerf dart did actually come out of that. Yeah, and that's all the other pieces working together. I think this was with the old barrel design, so you'll see a Nerf dart just sort of fart its way out the front barrel when I shoot it. Yeah, just poke his nose out. Yeah, I do. So you can remove the battery pack. That's just held in by magnets. I need bigger magnets. And that's the magazine. And there's no visible switches, latches, or anything. That switch is part of the gun design, so it all looks exactly like the original, just twice the size. This is the second predator. Am I? Sorry.
That's okay.
It's always, yeah.
In fact, pizza's getting cold.
Oh, yeah. This thing's like the second last slide. So.
Second last.
Okay.
Yeah, this is prototype 2. Remember that moving barrel design? So instead of cutting a cylinder in half, what I've done is cut it into 4 pieces. 2 on one part of it, 2 on the other part, and they can slide in between each other. That worked okay. I got about 3 out of 6 darts that I fired actually came out. So what's better than cutting it in 4? Cutting it into 10 pieces. So that's this part, which works great. I tested it just today, and I can shoot as many darts as I like now, and all these different prongs just slide between each other, and the dart stays exactly where it's meant to. Yeah, so that's prototype 2 under construction. I've got it with me. I can try and show it off quickly, but I don't know how much time.
I'll tell you what. I mean, we are going to go to the social event, so
Yeah.
probably not a great idea firing
Nerf
Nerf
Gun.
darts.
Yeah. Yeah. Okay.
Can you fire it now?
Maybe.
It's still kind of in pieces, not properly glued together. It might just make a lot of noise and do nothing.
That's yeah. So the you see, I've got to hold the. I need bigger magnets, but that's the lighting working on it. The other the other switch just might maybe. No. Did I put enough darts in it? Oh yeah, I did. Oops. Yeah, it does work. It has worked. I just I need to tweak things a bit.
Always a problem with live demos.
Yeah.
Exactly. Sorry for taking all of the time.
No, that's all right.
Yeah, thanks.
I am never getting that dart out again.
My big
Look, take the
problem-
man over this.
my big problem is when the